we're going to do, before we get started, we're going to do a little review of some symbols, some trigonometry symbols. And I might come back to some of these next unit, so we're not going to go through all of them. Does anyone know what this symbol here is? No? Yeah? Robin? Unknown angle. It has a name. And that's right. It's unknown angle. Its name is theta. It's part of the Greek alphabet. And it's an unknown angle. Okay. Does anyone know that symbol here?
Can I take a random guess?
Sure.
Bitwise?
No, not in that. Okay, it's similar. You've seen it before. Similar. Right, similar triangles, similar shapes. You can use that one. Whereas this guy, an equal to symbol with a similar on top. So we have two shapes that are not only similar, but also have the same angles. Yeah. Congruent. Congruent. All right, this guy, you probably know this one. Not equal to. The next guy. Angle. Yeah, this one's triangle. It's not always triangle. Its symbol is delta, and in trig, it's a triangle. In when we're doing linear relations and graphing, it's actually going to mean the change of, or even in physics, it means the change. So the triangle can mean change, but it also can mean triangle if we're talking about trigonometry. So it can have two meanings. And last one, we actually, I don't know if I showed you this one before.
I thought that was equal to.
Approximately equal to. Yeah. And we use this symbol equal to with a dot when we do what? It's very similar to approximately equal to. It's nearly equal to. We use it when we round. So rounded answer. With a dot above the equal to. Now, it's good to know those symbols if you haven't been told before. Yeah, so those are some symbols. Moving on. Does everyone have that down? Let's wait a second. I'm going to skip the angle properties for now. We're going to jump right down to the Pythagorean Theorem review. Okay. Good to go? Sorry, Jeremy. A squared plus b squared equals c squared. You've heard that one before. It's actually on your formula sheet. So again, you don't have to memorize it. It's the very top of the front page. Okay? But you probably know it.
Yes.
Probably. Good? Jeremy? Okay. Sorry. I don't want to rush you. Okay, so c squared equals a squared plus b squared. What's the most important side is which side to label correctly? C. C is going to be opposite the right angle. So it never shares the right angle. It's the hypotenuse of the side. Yeah, the hypotenuse. And it's, if you're not sure how to find it, it's the longest side, and it is always opposite the right angle. Okay? A and B, you can use, yeah, and it doesn't matter which one you label as A or B. You can use A for altitude, B for base, but it really doesn't matter. Okay? What matters is you get C right. If you get C right, you'll get the right answer. Be good to go. I do have a video today for you. Oh. Where is it? Oh, where'd it go? Did I close this and reopen it so you can see the video? I think so, hey? Oh, I don't know why it didn't load. Sorry guys, I'm going to pause the video. Mr. Vader.
Good morning, class. Today I will be teaching you the Pythagorean Theorem. It is your destiny.
It is your destiny.
We begin with a simple right triangle. If we know the lengths of sides A and B, we can calculate the length of side C, the hypotenuse. The hypotenuse is the long side of a right triangle, but I prefer to think of it as the dark side. Don't underestimate the dark side of the triangle. To find side C, you are free to use any methods necessary, but no disintegrations. The Pythagorean Theorem states that the sum of the squares of the two short sides equals the square of the hypotenuse. A squared plus B squared equals C squared. All too easy. Let's look at an example.
Okay. I don't even.
Side
That's
A
wrong. It's not
is
great. I don't know
5
why.
centimeters long,
Okay.
and side
Do
B
you want to watch
is
the
12
example?
centimeters long.
Yeah. Okay.
A squared plus B squared equals C squared, according to the Pythagorean Theorem. Take the square root of both sides to isolate C. So the square root of 5 squared plus 12 squared equals C,
It's important that
the
you
hypotenuse.
add those squares before you square root, right?
5 squared is 25. 12 squared is 144.
What does that equal?
The side is long in this one.
169.
Square root
Square root
of
of 169.
169 equals
Does anyone
C.
know that?
I have you now.
13.
13 equals C. The circuit is now complete.
Okay.
The hypotenuse of this triangle is 13 centimeters long. Impressive. Most impressive. Just remember, kids, don't be too proud of this geometrical terror you've created. The ability to calculate the length of the hypotenuse is insignificant next to the power of the force.
Okay.
Vader out.
Vader out. Okay. Isn't that funny how someone actually did that? I don't know. Okay, so we're going to solve for the dark side. Don't underestimate the power of the dark side. Okay. So, the first thing we want to do when you have a triangle is label C. Who's going to be C in this triangle? The X? Yeah, the far, the long side, the one opposite the right angle. Does it matter who A and B is? No. So we'll make A 12, the altitude, B. Okay, so we have C squared. Do you guys usually write A squared plus B squared equals C squared, or C squared equals? Okay. A squared plus B squared equals C squared. Let's fill her in. What's A? 12 squared plus 7 squared equals C squared. So what I usually do is before I square root, let's actually square and add these together so that we don't confuse BEDAS. Okay, square button on your calculator. You should probably know these squares, but I'm going to show you how to do this all in one step later. So 12 squared, you can two options. The x squared is the squared button, or you can go 12 hat power 2. It's the same thing. So this hat is the power of, or 12 squared. It's only one button. Okay, so 144 plus, what's 7 squared? 49. Okay, let's add that together. 9 plus 4 is 13. 4 plus 4 plus 1 is 9. So 193. Okay, where's the square root button? Well, it's opposite of the square. It's right there. So second square root, and I'm going to show you something. So if you're in your calculator, you typed in 12 squared plus 7 squared. It'll go straight to 193. Yeah, nice. And then watch this. Second square root. Now, say I had a really long number I don't want to type in, but it's my previous answer. Second negative will bring up your previous answer. The square root of my previous answer gives me to one decimal place. 13.9 unit. We need it at the end. What unit was this in? Centimeters. Equals C. So we took the square root of both sides. To get rid of that square, we have to square root both sides. And that's why we square rooted it. Okay. Now, if you wanted to type this in all at once, that's what Professor Vader was doing. He's square rooting both sides off the bat. So you could actually type this in as square root of 12 squared plus 7 squared. And there's my answer. All in one step. Okay, that's what Professor Vader was doing. Bare minimum, I want you to write that step down. Okay, the square root of 12 squared plus 7 squared. And then your answer. All right, what if we're not solving for the dark side? So let's first label the dark side, or C, hypotenuse. Who is that? 12, opposite the right angle. And then we'll make the other side A and 1B. So let's use A as altitude and B as base again. Now I have a question for you, because you're all coming from different schools. So does anyone ever use the formula? The side you're looking for, if it's not the hypotenuse, so A squared would be C squared minus B squared? Yeah?
Yes, but that's for finding the length if you know the hypotenuse.
Yes, if you know the hypotenuse, if you're looking for one side. So there's two ways you can solve this. You could either have the formula rearranged, and how we do that, basically, I just subtracted B squared to the other side to get A squared by itself. That avoids an extra step if you decide to do it this way. Either way is fine. I'm going to write down both ways. You write down the one that you like, okay? So A squared is actually what variable? So x squared equals, our C is 12 squared minus 10 squared, okay? If you did it this way, you would have had x squared plus 10 squared equals 12 squared. Either way is fine. So here, I'm still going to have 144 minus 100. This one I have plus 100 equals 144. So write down the one that you like. What's 144 minus 100? You know that. 44. Again, what would I have to do here to get x squared by itself? Before you can do square root, because we want x by itself. And right now we have plus 100. So you'd have to take away 100 from this side first, if you want x by itself. And then, yeah, and this is the other method. So notice how eventually you're going to get to the same thing. It's more steps to do it this way than it is to do it the subtraction way. It's going to be c squared minus the other side you know. So c squared minus b squared will equal a squared. Because what we're doing, if the formula is a squared plus b squared equals c squared, and this time I'm looking for a, I'm subtracting b squared to the other side to get a squared by itself. And that's how we get that formula. Okay, so square root of 144. So you could have even typed in square root of 12 squared minus 10 squared. If you'd like to do it all in one step. And one decimal place. I'll show the square root here. So I'd like you to show your work on your homework. I know you're so excited about that. Okay, so that means that you'll need to at least show the formula, one substitution, and your answer. Okay? All right, let's skip this one. It's too easy. Let's see this guy. Can you draw this picture? Where's your notes? Are you going to do your notes? So number 2, can you draw this picture, please? Oh, you're number 3? Sorry. I changed things. You're number 3. All right, skipped number 2 because I want to give you time for homework. Yeah, you're drawing it and solving it. At least draw it, bare minimum. Okay, so where does the 6 meters go? On the hypotenuse. Okay, that's the ladder. Is placed 1.2 meters from the base of a building. Where's that going to be? On the bottom. It says, how far up will the ladder reach? So we're looking for this height. We can call it A if you like. Okay, so who's C? C is 6 meters, and B then would be the 1.2. Now, who here likes the formula with subtraction in it? Okay, who likes using just A squared plus B squared equals C squared? Okay, most of you like the subtraction. So if I use the subtraction, because we're not looking for the hypotenuse, we know it, we're looking for A, I'd have A squared equals what minus what? C squared minus B squared. If you try to go B squared minus C squared, you'll get a negative, and you can't square root a negative. So that'll help you figure out you have an error. Okay, so what is C? 6 squared minus 1.2 squared. Could we type that all into our calculator? Yep. 6 squared minus 1.2 squared. 34.56. And then what do we have to do to both sides? To get A by itself? Are you guys with me? Yeah or no? Okay, what would we do now to get A by itself? Sure, Taylor. We did C squared minus, we got this number. Square root both sides, yeah, to get A by itself. Because the opposite of square is a square root. And that gives you, so you can go second square root, second negative, and 5.9 meters. Okay. Oh. Oh, okay. Yeah, no. This guy. How would you solve for x here? Nalina? Let's find y first. Sure, yeah, and then once you know y, then you can find x. Now, I need to talk to you about, we always have to use exact values. You never round to the very end of your answer. So if we're solving for y first, let's label c. Where's c? 9. We'll make y, so it'll be like this, our base, and a. So we're using the formula a squared equals c squared minus b squared, because we know our c value. So y squared is, yeah, Quinn?
I was just thinking, why even use y? Why not just,
Because, like, Pythagorean theorem only works for a right triangle. So we have to figure out y to figure out x. Because then we'll have two, right, yeah.
Because the other triangle doesn't, if you were to
You can't use this big triangle. It wouldn't be a right angle necessarily.
Right angle.
Yeah. Okay, so 9 squared minus 6 squared. So what is 9 squared minus 6 squared? 81 minus 64. 45? Okay, and we're going to square root both sides. And I'm going to show you a trick, because most of this is review, so we're going to build on what you already know. So when we square root both sides, I'm actually just going to leave it as a square root, as an exact value. If you don't want to leave it as an exact value, you're going to have to use your exact value in your calculator. So you could write down 6.7. We actually have to use this whole decimal place when we're solving for x. We don't round till the end. Okay? So when we find x, which is actually our c value over here, I'm going to show you something. So x squared equals our y, which is root 45 squared, plus 3 squared. What happens when you square root 45? Or you square the root 45. Well, if I square my previous answer, it's 45. Why does that happen in this formula here? So you're doing something and then you're doing its opposite operation. So you're square rooting it and squaring. Well, those are opposite operations. So this, as an exact value, is actually 45 plus 9.
Go left, and then right, and then left again.
Right.
Left.
Okay, so square root of 54 to the nearest tenth, what's your answer? The nearest tenth. So plus, 3 squared, and then square root of 54, 7.3 decimeters. Okay?
7.4.
No,
No, you round down. It's 7.348. 8. The 8 rounds the 4 up.
no, you never double round. You never double round. So we only so who cares whatever? We just drop the rest of them. We're mean. Just look at the number before. Okay? All right. Where did I get the 9 from? Oh, 3 squared. 3 squared. Okay. One more example, and then you can start on your homework. I want you to try and figure this one out. Or should we do it together? Oh, yeah. Try and draw that and figure that one out. Try and draw that. Standard of excellence. So usually standard of excellence, there's only going to be about 20% of your questions on your test will be standard of excellence. 80% are acceptable standard for the curriculum. So your curriculum there's different curriculum bullets, and some of them are standard of excellence, and some of them are just acceptable. So solving Pythagorean Theorem, that's actually part of the old curriculum, but if it was like, it would have been, solving Pythagorean Theorem would be acceptable standard. Solving Pythagorean Theorem when you have like a square is standard of excellence. And the reason why is, well, you'll see. You have to use algebra. So it's more than just Pythagorean Theorem. So usually things with double operations are standard of excellence. Yes.
Are we assuming that this triangle is it's a square?
Yeah, it's a square. Okay, does everyone have this down? Okay, draw your best square. Okay, now a square is all sides are the same. What else is true about a square? They make isosceles triangles with the diagonal. Yeah, what else? They're the same triangles when it's split. Yeah. They're right. So we know these are all 90s here. Right? So when we draw this diagonal, it's like that. Okay, it says the diagonal of a square is 13. Find the length of the side. So what do we know about those two sides? The same. So what are we going to call them both? Choose a letter. A or X? So let's make them both X because they're the same. So we have our formula. C squared equals A squared plus B squared. Who's C? 13. So 13 squared equals X squared plus X squared. What's X squared plus X squared? 2X squared. So 169 equals 2X squared. Now what? What's the next step? Yeah, Zach? You divide it by 2. We want x by itself, which is, I know this, 84.5. And then what? Last, square root both sides, which gives you 9.19, 9.2. Well, or you can do this step. You can go right to your substitution and do your algebra and answer.
Way, but it's still the same answer.
Show me some work, just some work, okay? What'd you do?
Well, what I did was I actually put an x in the square,
Okay.
and then the x in the square, this here is a 90-degree angle, as well as this, and this, and this. So what I can do is divide 13 by 2, and that'll give me 6.5, and then the square root of 6.5 squared plus 6.5 squared. And that gave me the same answer.
Oh, you made a smaller triangle?
Yeah,
I'll still take a look.
Do you want me to draw on the board instead, or?
No, I see what you're saying. You're saying that this is going to be a 90 right here. That's what you're doing.
Yeah.
Yeah, I gotcha. You did that.
Yes.
In this case, not always.
Well,
In a square.
It only works for a square.
Right, exactly.
But the other answer only works for a square as well.
Right, both methods. Okay, so he was drawing an angle here. Right.
I drew second-minded, and then I just figured out.
So 6.5. 6.5. Yeah, that would work too. Yeah. Okay, so your handout, it's actually 1 through 7. 8 and 9 is optional. The solutions are on the next page. I'd like to see, so on page 20 is your homework. Oh, sorry, just 8 is optional. So 1 through 7, I'm going to actually draw number 4 for you right now because it's really confusing. So what it's saying is there's 2 buildings. There's an 8-meter ladder. So say it's like anchored down here. When it's going that way, it goes up 6 or 7 meters. When it goes the other way, it's supposed to be the same length. Actually, sorry. Let's try that again. Let's try this line again. It only goes up 6 meters. Okay, so that's what 4 looks like. So you might want to draw that on your sheet beside number 4. So you have to find, like, if you call this guy X and Y, and then add them together. Also, C is supposed to be a right angle. I don't know what happened to the little box. So 1C should have a little box in there. Okay, it is a right angle. Okay, so if you can, most likely this would be a good place to start doing your homework in a workbook. There's not much room to show your work on this book, in this worksheet. So if you can do it on another piece of paper, and then the answers, check your answers are on the next page, page 21. Okay?